This is worksheet 2A-0, internal forces that apply the concept of normal and shear stress for a cut other than the traverse cut that we have in lesson 1. So basically you can do this problem without going to lesson 2. So I suggest you to practice before go to lesson 2. The two wooden members of uniform cross section are joined by the simple scarf splice shown. So that is a simple there. So that the two portion of the wood. Knowing that the maximum allowable tensile stress, so tensile stress, that is the normal stress that in compression in the glue splice is 75 psi. So determine two things: the largest load P that can be safely supported and the corresponding shearing stress in the splice. So from that you can separate a member, and let's consider the bottom one. So we have here, we have there, that the cut that you have for that member, and the load P going down, P, and it in 3D, and you can see that here. So at that cross section in the splice, you can see the sigma, the tensile or normal stress, it will be going out because that is in tension. The 2P go up, down, tend to extend the wooden part. So from that, as you can see here, the tensile always stress is always perpendicular to the section that you cut and go up the cut in this case, because it is normal and in tension. And for that one, that is a sigma that we are talking about. Okay, and from that we can go ahead to find out number A. The question is the largest load P. It's shown in there. So the restriction that we have is the give you the maximum tensile stress, allowable tensile stress. So as you can see here, restriction is the tensile stress. So basically the normal stress that is in tension equal to 75 psi. So what does that mean? You can have sigma on that plane, and when we say that plane, it is the splice. Equal to 75 psi. So that is the allowable, maximum allowable tensile stress. And from the lesson 1, we already know the equation for normal stress with that cut face. So we have sigma from lesson 1 equal to P over the transverse areas times cosine theta square. Just one tricky here, the theta is derived from the transfer, not the 60 degree in there. 60 degree vertically from the transverse is being perpendicular to the longitudinal axis. So if we draw the line longitudinal axis in there, the angle theta in that equation should be here, and as you can see, is that what the theta defined, not along the longitudinal axis, but perpendicular to the longitudinal axis, which is from the transfer. So from that you can see theta in that equation equal to 90 degree minus 60 degree equal to 30 degree, not 60 degree. So whatever they give you, the number, you need to know, okay, with that equation, what is theta, what is p, what is 80, etc. So don't just get the number that they give you and apply in the equation, where the equation that they define different parameter in there. So from that we can have AT inverse. So that one, they give you the cross section 3 inch by 5 inches. So we have 3 times 5, so we have 15 inch square. And the angle theta, like I say, angle theta is equal to the angle measure from the transverse cut, right? Measure from transverse cut. And as I mentioned earlier, theta in this case equal to 30 degree, not 60 degree. So from that, they give us sigma, maximum allowable tensile stress. They give us 80 and theta, so you can apply in that equation to find out. So here you can plug in sigma equal to 75 psi equal to p over 80, 15 cosine 30 degrees square. From that you can get p, which is the largest load ever, equal to 1500 pounds. And why maximum? Because that is the maximum allowable sigma with the associated largest load P in here. So the P have to be 1500 pounds or less, so that the spline will not fail. It not separate the two part of the wood. That is the first part. And then go to B, the corresponding shearing stress in the slide. So that should be easy now. B corresponding shear stress. And we already learned the equation. Shear stress is tau, and tau in this case equal to P over 80. Do you recall that? Then sine theta cosine theta. We have already have P, 80 and theta, so plug in. We have 1500 pounds divided by 80, 15 square inch. Sine 30 degrees cosine 30 degrees. From that we have tau equal to 43.3 pound per square inch. So it will be psi, and that should be the corresponding shear stress answer. So that we have sigma given, and we find out the load P, so opposite what we did in lesson 1, and then the corresponding tau. For the corresponding tau, as you can see, the tau is like we put it in green here, it parallel to the cut face. So it's parallel, and in this case it will be the tau, that is the tau on the face, So that is a tau, and that tau equal to 43.3 psi. With that, we done for the worksheet 2A-0, and now let's go to the main lesson for lesson 2.